Hey guys, I'm Saeed, a security engineer at Google and a certified Kubernetes enthusiast. I want to kick off a new series with this video. As you've probably seen from the title, I've named it Unconventional Attack Vectors. Of course, I'll be focusing specifically on where my speciality lies, and that being Kubernetes. So if you watched the last video, you'll know that I've recently been sort of contributing to the Kubenomicon, which is a one-stop shop for Kubernetes security. It sort of details all of the latest and hottest attacks and their respective defensive strategies. And in doing so, working on a segment which concerned admission controllers, I came across a very interesting attack that I thought would be quite handy or quite useful to share with you guys. And that is actually, before I go into things, maybe it's be nice if I give a very high level of what admission controllers are and how things fit into the grand scheme of the Kubernetes environment. So typically, if we're talking about security, we're talking, a lot of people think authorization and authentication. And with Kubernetes and the way security is set up with Kubernetes, there's actually another layer to security, and that's admission controllers. Now, Kubernetes have this pretty neat way of adding an extra layer of security with admission controllers, specifically two kinds of admission controllers. We have validating and we've got mutating. Now, let's talk about validating first. Validating effectively takes a webhook, right? A web request, because Kubernetes effectively is just an API, isn't it? Really, under the hood. It will take that request and it will validate the request based on a given condition. And then you've got mutating admission controllers. And that's what we're looking at here. Mutated admission controllers is kind of like a knife. You know, you could use it for, slicing an apple, or you can use it for killing someone. It's quite dangerous, and also, can of course be quite good depending on how you use it. So that being said, unconventional attack vectors, number one. So the attack, a compromised admission controller can be a master of disguise, right? It could be hidden anywhere. So here we've got a regular pod manifest, right? It looks perfectly normal. You probably deploy this, or maybe even have the manifest sitting somewhere in your environment, maybe on a Linux host somewhere, or even in a repository, right? And the same case can apply for Helm. So don't think you're safe if you're using Helm. It's not just deploying pod manifest. It's just using this as a simple example. As such, with mutating admission controllers in the wrong hands, this could potentially be your manifest. All of a sudden, you can see here the difference. If I maybe zoom out ever so slightly, yeah, if I put them side by, I don't know if I can put them side by side actually. There you go. So here you've got the your innocent pod definition file, where you've got a standard pod, here you've got, my app and a single container named my container and the Nginx image, right? And all of a sudden, your regular pod, right, with the same name, the same container name, is now running a different image to what you initially had intended. Now running attacker controlled image. And hey, hang on a minute. I didn't allow escalated privileges. So how did that happen? All of a sudden, this pod is running escalated privileges, which is very dangerous, very scary. Not just that, we've also got a second infiltrating container. We've got a sidecar container that's been hidden into our app, crypto miner. The name's quite self-explanatory. So this doesn't happen, all of a sudden. It doesn't happen randomly. Of course, threat actor would have already, compromised your cluster. So obviously take the different means to, of course, secure your cluster, which is very, very important. And I can't stress that enough. Now I want to talk a little bit about how this may happen. So how would a threat actor be able to do this? So we're going to look at a segment of the code that it takes to actually mutate your manifests to actually allow threat actors to effectively intercept those webhooks and make those changes to your manifests. So admission controllers are written in a language of your choice. I think there's a not select number of them. I'll share the link to the admission controller section in the Kubernetes documentation. This specific one is written in Go. Golang. This is just a function, the thick of the actual code. So I thought I'd just share that with you. So the function takes an admission controller object, as we'd see here in the parameters, and it returns an admission response, right? Pretty standard so far anyway. And then here it declares a variable of the struct core v1 pod. That's a pretty interesting way to actually sort of store the data of the payload that we unmarshal in just a moment, and I'll explain how that's done. Here we effectively unmarshal just below that, and that's effectively the process of converting JSON data into a Go struct, right? And that allows you to basically sort of mutate the payload, play around with it. So, it takes the raw JSON representation of the pod from the admission review and then populates the pod variable with that data, as we can see here, just in those parameters right there. So that allows you to work with the pod as a struct. But this is where the dangerous part of the code is, really. Here is where the actual mutation happens. So we can see here that the image, right, within the container index 0, which is obviously, position 1, is changed. The image is changed from whatever it was, and that doesn't matter, to this attacker controlled image. Secondly, it takes the security context, regardless of whatever it was, and it sets that to true. And then thirdly, as we've seen in the manifest above, it appends a secondary container, so a sidecar container. And here it's provided the name, crypto miner, and the image, crypto miner latest. And then it, of course, marshals the Go struct back into JSON such that it returns that admission response to the API or to the database. So that's quite dangerous, and of course malicious. And it's really important to understand what is going on, before we could actually, mitigate a compromisation. It's important to understand what could potentially effectively lead to a compromise, as at such a scale. So it's important to obviously also note that the code is obviously intended for educational illustrative purposes, strictly to, of course, demonstrate that potential attack vector. So yeah, obviously you shouldn't deploy this into production or any other environment. And I mean, to defend from that, you could talk about a number of different things. Of course, it's important to obviously only acquire admission controllers from vendors that are of course have good reputation, of course, and not to pull random code from anywhere. It obviously, some of the other more basic and standard steps to be taken, like principle of least privilege, I'm sure I don't have to tell you that too much, are back, of course, to be vigilant, making sure that we test and validate admission controllers in all environments. It's not just production. This is from right the way from your lower environments to of course your more sensitive environments. Image verification, that's also important, and regular updates, making sure that the Kubernetes clusters are regularly updated, and of course the admission controls are regularly updated too. So I won't be reading too much from the document because I'd like to save that for you guys. I'll add, or I'll plug the Kubenomicon down below. I've actually contributed into the mutating webhook, or the malicious admission webhook section. So I'll leave the reading for you guys, and yeah, definitely looking forward to hearing what you guys think about this, these new and interesting and innovative attacks. I'll be looking forward to sharing more videos like this. So let me know if these sort of videos are your cup of tea. But yeah, without further ado, I'll see you on the next one.